Okay, for this video we are going to discuss the chapter 5, which is Ethernet. Ethernet is the most widely used LAN around on technology today. Ethernet operates in the data link in the physical layer. It is a, it is a family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. It is bandwidth of 10 MB per second up to 10 100,000 megabytes per second. The LCC sublayer handles the communication between upper layers and the lower layers. This is typically between um the IPv4 packet that adds. Okay, LCC is implemented in software, and implementation is independent of the hardware. Okay, and the MAC sublayer is a lower sublayer of the link layer, not implemented in hardware. If the LLC is implemented in the software, so the MAC address is implemented in the hardware. Next, but first, wait. Okay, let's continue. Um, the MAC sublayer, as shown in the figure. Okay, you can see that the MAC sublayer has two primary responsibilities: the data encapsulation and media access control. Data encapsulation is the frame delimiting, addressing, and error detection. The media access control is control a frame placement on and off the media and media recovery. Um, okay, the data encapsulation. It includes the assembly before the transmission. So, data encapsulation is data will be encapsulated. The packet data will be encapsulated by a frame, and the frame delimiting is frame process that um, provides important delimiters that use to identify a group. So the frame delimiting is the one who's responsible to identify the group of bits that make up the frame. And the addressing encapsulation, it provides the data link layer addressing, which is the MAC address, the destination MAC address, and the source MAC address. The error detection, each frame contains trailer used to detect any error in the transmission. So I will notice that it has an error. That's why if there's an error, um, the error detection detect that there's an error. So media access control, okay, a secondary responsibility of the MAC address. Media control is responsible for placement of frames in the media and removal of frames. Okay, the media access control is responsibility of frame to be to on becoming a bits on the media. I think that's what I understand. Then Ethernet evolution. Okay, these are how the Ethernet change year by year. Next is Ethernet frame fields. Ethernet frame fields always has a preamble and start frame delimiter. Preamble is the 7 bytes, and the frame delimiter is the 8 bytes. So the preamble with a start frame delimiter composed of 8 bytes, and it used for synchronization between the sending and receiving devices. Then the destination MAC address is the identifier for the intended for the recipient of the message that the source MAC address will going to send. The ether type is a 2-byte field. The source MAC address and the destination MAC address is 6-byte field. The data is 46 to 1500 bytes, contains encapsulated data at the higher layer. Oops. And the FCS, the frame check sequence, it composed of CRC, cyclic redundancy checks, to check if there's any error, to help check on any errors. Next. The MAC address and hexadecimal. MAC address is composed of hexadecimal values, which, as we can see here, this is the conversion of decimal to binary and binary to hexadecimal. And here, as we can see here, um, this is the conversion of the this is the hexadecimal numbering, select the decimal binary and hexadecimal equivalents. So it's a 48-bit binary. So there's a 8 octet, a yeah, hexstat on a um MAC address. Am I correct? Hexadecimal. Okay. So decimal conversions between decimal and hexadecimal values. Then MAC address identity. Then too slow. The first 24 bits of a MAC address is organizational unique identifier. It is from the OUI, and the other 24-bit is from vendor assigned and NIC interfaces. It composed of it it both of it composed of 6 hex digits. Okay, and the next uh, what I'm doing is explaining these figures so that so that so that it will clarify all of us on what those figures are doing. I need to send information to H3. So the destination address, source address, the data is not addressed. I shall ignore it. So the frame forwarding, it will going to send a frame to all of the hosts inside a network. Then they will notice that that message is not for them because of the MAC address and the IP address. Next, MAC addresses representation. You can see your own MAC addresses by just typing on the CLI or command prompt the IP config /all. It will list all the IP configurations on your device. The MAC address can be represented with dashes, colons, and with periods. And Unicast MAC address. Let's play the figure. I need to send frame to the server, so it will find the destination MAC address to forward this data, this user data. Next, broadcast MAC address. The broadcast MAC address is always f-ff. That if that is the destination MAC address, the host will going to send all the devices uh, of the data that it wants to send. It will broadcast. It will broadcast the oh on broadcast MAC address. The destination MAC address must be broadcast, and also the destination IP. Forward a broadcast frame to all the device on the LAN on the network. Next, multicast MAC address. Multicast MAC address. The destination is 01005E00C8. It will going to send data to date. It will going to send. We're going to flood all the ports that are connected to the switch. Then it will host. If the host send data, the 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 message data will going to all of these devices. But if the MAC address doesn't satisfy doesn't pag hindi katulad yung MAC address ng host and the receiver, the frame will be dropped. And if the MAC address is like the if the destination MAC address is correct, the what to call this the devices will accept the data frame. Next, switch fundamentals. Okay, learn examine source MAC address. Okay, the source MAC address is a short of MAC 00A. Okay, and it there are they are connected to a port 1, 2, 3, and 4. The next learning MAC addresses. If the source 00-0A wants to send a message, its source MAC address will be listed on the MAC address table, and it will plug all the ports. Okay, because the MAC address of the source doesn't is not on the MAC address table, so it will go into plug all of the ports. And then next, filtering frames. So so the source is this is 00-0D, so it will go into a so wala po siya sa table, then ang gagawin niya ay ipa-plug niya sa lahat ng ports. Hindi. So malalagay siya sa table. Then its destination MAC address is already on the table. So what it will going to do is send a unicast. It will going to send the message to its destination port. And the MAC address we're going to send back to OD 000. Frame forwarding methods on Cisco switches. Frame forwarding, it can be a store and forward or cut through. Store and forward receive the entire frame and computes the CRC. The CRC is valid, which looks up for destination address, which determines the outgoing interface. The frame is then forwarded out to correct cut through switch forwards the frame before it's entirely received. At a minimum, the destination address of the frame must be read before the frame can be forwarded. Okay, let's see. Store and forward switching. Oops, destination source data CRC. We're going to send it to the switch and the CRC. It's correct. Then it will forward the it will add the switching table and it will forward to the destination. Okay. Every time on store forward that you will going to send the frame, uh, when it enters the switch, it will check the CRC, and if the CRC is correct, so it comes from the right port, then it will forward it to its destination. Let's proceed. It's now cut through switching. Cut through switching is get destination switch send and switching table and source and group and the cut through it is a very fast switching method than a store forward because it offers the lowest level of latency of the delay. Switching immediately forwards packet after the reading the destination address on the switching table. Then fragment free switching, and the fragment free switching, the switch stores the first 64 bytes of the frame before forwarding. If the 64 bytes is stored, the fragment can view as a compromise between store and forward switching as fast as switching. So it will going to send the frame. Next is memory buffering on switches. Port-based memory, port-based memory buffering. Frames are stored in queues that are linked to specific incoming and outgoing ports. So, para silang nakapila sa pinapasokang port at lumalabas sa port. And shared memory buffering deposits all frames into a common memory buffer, which all the ports on the switch are shared. Okay, nakastore lang sa lahat ng frames dun sa isang memory buffer, which all na pinaghati-hatian lahat ng port. Okay, the port frames stored queues are specific incoming outgoing frame and frame transmitted to the outgoing port only when okay. Shared memory buffering, shared memory buffering, common buffer that all the ports on the switch share. The amount of buffer memory required by a port is dynamically allocated. Okay, they are dynamically allocated on the ports. The frame and the buffer are linked dynamically to the destination port. Okay, let's proceed. Duplex and speed. The full duplex is let's see. Duplex is full speed 100 Mbps to 100 Mbps. Okay, the full duplex is, for example, PCA send a message to S2, and the S2 also send a message to PCA. Na mabilisan din. And half duplex. On half duplex, one only end to the connection can send at a time. So if a PCA sends to S2, after the S2 receives the what PCA sent to it, that when the PC2 will able to send a message. Then auto negotiation option. Okay, duplex mismatch. By the way, the duplex should be same so that there's no duplex mismatch, and so if full duplex, the other one should be a full duplex, so otherwise it could be duplex mismatch. to avoid collisions. And then one of the most common causes of performance issues to 10, 10 over 100 MB per second Ethernet links. So that to avoid duplex mismatch, the S1 should be if the S1 is full duplex, the S2 must be full duplex also. If the S1 is half duplex, the S2 should be half duplex also. And auto MDIX is it it is a type of connection that detects it is a type of either the for example either um, or the MDIX determines the connection required to configure the interface accordingly. So it's like it's automatically know what type of connection required and conf- required and configures the interface accordingly. And the auto MDIX feature is enabled by default. So if you buy a new switch, it already has an auto MDIX feature in it. And next, destination unsafe network. So on communicating on local network, if the IP address is correct and also the destination MAC address is correct, it will able to send a information. The physical address, the MAC address, and the logical address is always the IP address. The layer 2 Ethernet frame contains a destination MAC address and um on a source MAC address, and the layer 3 IP packet always have a source IP address and destination IP address. Next, if you want to communicate to a remote network, the original source has its um has its own MAC address and IP address, and the the source MAC address will going to going to wait the destination MAC destination IP address is will know will know by the original source. So the source will going to send uh, the message to the router, to the destination MAC address, to the MAC address of the router, and the and it will become mm, the source MAC address until it reaches the file server to send the data. Then introduction to ARP. I need to send information to, but I only have. Okay, the ARP, the Address Resolution Protocol, destination MAC address of the Ethernet and Ethernet network interface card, which will either be MAC address or final destination. And next, okay, resolving IPv4 addresses to MAC addresses. So the ARP process is it will going to plug all ports with the IP address and if the IP address is the same of the host, it will going to send an I think ARP request. Then after it sends an ARP request and receive the host, the ARP request sent by the sender. The sender will going the destination will the destination IP address will going to send its MAC address to the sender, and the sender will able to send a message to the and when the sender receive the MAC address of the destination IP address, the sender will able to send a message to the receiver. Okay, the ARP reply is the ARP rep, the ARP reply is the MAC address of the here the ARP reply is the MAC address of the receiver, and the ARP request is will be sent by the sender. Okay, removing entries from an ARP. Uh, so in removing entries from the ARP, it has a 2 minutes time. So if the ARP of the so the if the MAC address will not be used for in 2 minutes, so the ARP cache will automatically delete it after 2 minutes. So this is how we able to show IP ARP on our CLI, or simply type the command ARP-A on our command prompt and show IP ARP. We are going to type it on the privilege exec mode, and then we are able see to see the hardware address, type, and interface on where it is located. Also the IP address and the minutes. Next, ARP broadcast. ARP broadcast is the method of ARP to gather the MAC address of the receiver's MAC address, so that the sender will able to send a message to the receiver's MAC address. Then ARP spoofing. What is an ARP spoofing? ARP spoofing is is an ARP reply that pretend to be the default gateway. So ARP requests the need MAC address to default gateway 192.168.1.1. So this ARP an ARP spoofing, the ARP replied from another device will pretend that it is the default gateway, so that he can access to your so that you will going to send the data to that MAC address, because it will replying its MAC address. So what the computer think will be will that you are the default gateway, and it will going to send you the data that it's planning to send to the default gateway. In some cases, use ARP can lead to a potential security risk. Uh, that will happen because the ARP will going to plug every port. Then, if one data, if one of the devices send an ARP reply, it will going to pretend that uh it might be pretending that it is the default gateway that you will sending information here. This is the explanation for that, for you to be clarified. The attacker sends an ARP reply with its own MAC address. The receiver of the ARP reply will add the wrong MAC address to its ARP table and send these packets to the attacker. That's what happened. That's what I explained a while ago. The It will send an ARP request, and this will pretend that the ARP reply is for him or for this device. Then, if it sent reply, if the host A received the reply, it will going to send the packets to this malicious host. Let's pretend. Let's proceed. So that's all for chapter 5. I hope you understand something, and I hope to you learned something from me, and thank you for watching. I hope you like the video.